Okay, guys, so let's continue going on with our notes. So if we go ahead and look at number 5, it says 4 times the square root of 12. So again, we are just going to focus on the square root of 12 right now. We're just going to leave that 4 times out front. So the square root of 12, what is the largest perfect square that goes into 12? And again, look at your list if you're not sure. It's going to be the square root of 4 times the square root of 3. 4 times 3 gives us 12. So from there, I know that the square root of 4 is 2. So now I have 4 times 2. The square root of 3 can't simplify, so that stays the way it is. Then I can do 4 times 2. Now they're not underneath the square root. 4 times 2 is 8. 8 root 3 would be my final answer. Okay? Last one, over here, number 6. Same thing, just going to focus on the square root of 147 first. So if I look at that, I need to figure out what is the largest perfect square that goes into 147. So go ahead, take a second to do that on your own. And if you want to pause the video, you are more than welcome to figure it out, but I'm going to go ahead and keep moving on. So I have 1/7 times the square root of 147 can be broken up into the square root of 49 times the square root of 3. And that's good because the square root of 49 is 7. So I would have 1/7 times 7, and then the square root of 3 would stay. 1/7 times 7 is really just 1. So you can write 1 root 3, or how we would just write it is root 3. So that would be our final answer for that problem. Okay? So that was just simplifying square roots that were not perfect squares. Now we're going to look into multiplying them. So not only are we going to be simplifying, but then we're also going to multiply. So the strategy that I think that would be best to use is to first simplify the radicals. So I'll say simplify individual Why can I not spell individual right now? So simplify the radicals. I'm having like a brain fart there. Okay, each one separately. Then multiply coefficients and multiply radicands. You'll see what that's about to look like in just a second. Okay. So when I say simplify the radicals, I mean I have the square root of 8 times the square root of 6. What I would suggest doing first is seeing, can I simplify either one of those separately? And I can simplify the square root of 8. Okay, I can simplify the square root of 8 because I know that that's the square root of 4 times the square root of 2 times the square root of 6. Square root of 4 is 2, so now I have 2 root 2 times root 6. Now what you can do is multiply any coefficients and multiply any radicands. You can only multiply things together that are outside or that are both inside or underneath the square root. You can't multiply something where one of them's outside and one of them's underneath. You can't do that. So I can, however, multiply the square root of 2 and the square root of 6. And if you think about it, this square root of 6 is kind of like a 1 out front. So 2 times 1 out front is just going to stay 2. And then the square root of 2 times the square root of 6 is root 12. Then you check to see, can you simplify root 12 anymore? And in this case, the answer is yes, you can. So what I would have here then is 2 times the square root of 4 times the square root of 3, which is the square root of 4 is 2. So 2 times 2 root 3, which is 4 root 3. Okay? Another way you can do it, and I'm going to do this in number 8, and you can choose which way you like best, is you can multiply them together first and then simplify. It's just really up to you. It's really up to preference. Sometimes when you multiply them together first and then simplify, the numbers get a little bigger, so it can sometimes be harder to find what the perfect square is. Either way, that was totally fine with me. So let's go ahead and do it this way here. So the square root of 2 times the square root of 18 would be the square root of 36. I'm going to multiply 2 times 18. It's a good thing we did it this way for this problem because the square root of 36 is just 6. So that would be my final answer. It actually becomes a perfect square there. Okay, we'll do it that way again here in number 9. So here we're not going to simplify individually. We're going to go right to just multiplying what we can. So 3 times 2 gives me 6. Square root of 12 times the square root of 6 gives me the square root of 72. So then you have to start going through and thinking about what is the largest perfect square that goes into 72. And you would end up with 36 and 2. So 6 times the square root of 36 times the square root of 2. That would give me 6 times the square root of 36 is 6 times root 2. 6 times 6 is 36. So 36 root 2 would be my answer. Okay. Last one we're going to look at, number 10. Here, what I'm going to do is multiply the -4 and the 3. So -4 times 3 is -12, and I'm going to multiply the 8 and the 10 because they're both underneath the radical, so the square root of 80. Then I need to figure out what is the largest perfect square that goes into 80. The answer is going to be 16. So -12 times the square root of 16, and it would be 16 times 5 that gives me 80. Then from there, -12 times the square root of 16 is 4 times root 5. So -12 times 4 is -48 root 5. Root 5 cannot be simplified, so that would be our final answer. Okay? So very last thing we're going to look at, what happens if you don't find the largest perfect square number that is a factor? What if when you're going to simplify this, you don't find the largest perfect square? So let's look at the square root of 320. Let's say I know 4 is a perfect square. So I said, okay, I know that 4 goes into it. So what I would do is the square root of 4 times the square root of 80 multiplies the square root of 320. Square root of 4 is 2 root 80. You would have to always keep checking, just like I did. I always said, like if we look here at number 7, well, root 3 can't be simplified, so I know I'm done. Root 2 can't be simplified. That's how I knew I was done. Root 5 couldn't be simplified. But here you would have to look and you would have to say, can the square root of 80 be simplified? Well, it can. Let's say you didn't think of the largest one again. You just thought of 4 again. So I would have 2 root 4 times root 20, because 4 times 20 gives me 80. Square root of 4 again is 2. So you would have 4 root 20. Well, then you look at that and you say, is 20 simplified all the way? It's not, because a 4 can go into that as well. So then you would have 4 times the square root of 4 times the square root of 5, which is equal to 4 times 2 times the square root of 5, which is 8 root 5. So then you would look at that square root of 5. That's simplified all the way. So don't necessarily always stress about finding the largest perfect square the first time if it's taking you a while. Find a perfect square that works. Start getting the numbers smaller. You can see, yeah, it took a lot more steps. What you could have figured out was that 320 is 64 and 5, which would have gotten you right to this answer. But for some people, that doesn't come naturally to figure that out. So figure out a perfect square that works and then go from there. You don't necessarily